In our conclusion, we want to do two things. We need to first of all decide, can we make the call? And we decide this looking at the confidence intervals. So this is a step up from year 11 where you looked at whether the median was inside the middle 50% of the other group. Now we're going to use the confidence intervals, which are a much more accurate measure of what the population median may be. We're going to use that to determine can we make the call or not. Once we've done that, we then need to go on to make an inference. An inference is making a suggestion about what would be true for the population based on our sample information. So here is the formal definition of what we can do when we can make the call or not. So we've gone into and explored what a confidence interval is, and a confidence interval, remember, is looking at a range of values around the median that if I did another sample and got a slightly different median, it's given me the range of values that median could take. So the rule for making a conclusion is this part here. To make the claim that group B median tends to be bigger than group A median back in the populations, we are looking to see whether those little confidence intervals around the median, whether or not they overlap. So if they don't overlap, then we can make the call. If they do overlap, we can't make the call. So to make the call, and that means that we've got enough evidence to say that there is a difference between the medians of the two groups, we're looking to see, do those confidence intervals overlap? If the confidence intervals do overlap, then there is not enough evidence to say that the medians are different. Okay, it means the medians could be the same. If the confidence intervals do not overlap, then that means the medians are far enough apart. So we have got enough evidence to say that there is a difference between the two medians. And we can then go on to say which median is bigger. So when we need to look at, can we make the call, and we need to look at whether or not the confidence intervals overlap, and we're either going to do this by looking at the blue lines, or we can look at the values, and I'll explain both methods and you can choose which one you find easier to understand. So here's my confidence interval of my baby weights for mothers who smoke and mothers who don't smoke. That's looking at the weights of those babies. So I've just drawn a solid red line there, okay, and I've gone and found that's a birth weight of around about 2,800 grams. And when I've drawn that red line, we can see that it cuts through both confidence intervals. So it cuts through the confidence interval for the no group, the mothers who don't smoke, and it cuts through the confidence interval of the yes group, the mothers who do smoke. So the question we ask ourselves is, do those confidence intervals overlap? And if I can draw a straight line like that, that cuts through both confidence intervals, that means that yes, they overlap. Alternatively, I want to look at, does one value, one endpoint for one confidence interval, does that value there, and I've circled that, that's at 2,775.8 grams, that's for our mothers who don't smoke, and I want to see, does that value lie between the confidence interval for the yes group, which is our mothers who do smoke. So here are my limits for them. So I've got a limit of 2,500 and an upper limit of 2,900. And I'm asking if the value for the no group of 2,700, does that lie between the values for the yes group? So does 2,700 fall between 2,500 and 2,900? And yes, it does. So when we ask ourselves the question, do the confidence intervals overlap? We can say yes, they do for this example. So now we need to think about, well, what does that mean? So it means that we cannot make the call, and that means that the medians of the two groups could be the same. They might be different, but we haven't got enough evidence to detect if there is a difference or not. So how do we write this in a conclusion? Well, we need to be very specific, and the key idea here is about whether we have enough evidence to say that there is a difference or not. And in this case, we do not have enough evidence to say that the median birth weight of babies born to mothers who smoke tends to be smaller than the median birth weight of babies born to mothers who don't smoke for babies born at the Bay State Medical Center, USA in 1986. So I've gone back to the wording of my investigation question right at the beginning, where it talks about comparing the median birth weights of these babies and what population they came from. So that's why I'm being very specific about what I say in my conclusion. I'm then going to go on and make an inference. And what we're going to say is our sample from this medical centre suggests that we do not have enough evidence for a difference in the median birth weights of babies born to mums who smoke or do not smoke. So I can extend this sample result to the population of USA. Now, I don't have enough information to be able to determine whether it's a good inference to make or not, but I'm going to assume that the population at Bay State Medical Center is representative of mothers and children born in other parts of the USA. So I'm going to infer that for the population of USA in 1986, it's likely that there is not enough evidence that the median birth weight of babies born to mothers who smoke is smaller than the median birth weight of babies born to mothers who don't smoke. So those are the two things that I need to do, is I need to make the call and say what that means and be specific about for the sample that we have, and then we need to make an inference about the population and whether or not that this result may apply to that population.